Okay, in this example, let's look at it in detail. Okay, so this is a simple cell. How do we know? Because first of all, this is a voltmeter. I have a more reactive zinc electrode and a less reactive copper electrode. Okay, so this is a simple cell, right? So more reactive, they tend to lose electrons. So my electrons will flow this way and this way. Electrons get attracted to the positive plate, right? And then reduction is gain, and then red cat. So this is the cathode. Okay, and then the reverse side is the anode. Okay, and this is where oxidation occurs. So what is the oxidation? It's this reaction where my zinc metal dissolves to form Zn2 plus. All right, so there will be Zn2 plus in the solution because the zinc metal dissolves. Okay, and then the electrolyte that I'm using is copper sulfate. So copper sulfate, there's Cu2 plus, and then because it's aqueous, there's also H plus. All right, and then these cations gets attracted over to the cathode. Okay, so now I have in ranking of reactivity series, I have my Zn2 plus, Cu2 plus, Zn2 plus, H plus, and Cu2 plus, right? Can make a zoo, however, cannot, okay? So the least reactive metal will gain electrons. So copper will gain these electrons from this circuit over here. Okay, so what is going to happen? My Cu2 plus will gain electrons and it will form copper solid metal. Okay, so observation, my zinc electrode dissolves, and then the red, brown, or pink copper solid coats around the cathode, and my cathode becomes bigger. Okay, so what happens to the electrolyte? Since my copper gets discharged, right, my blue copper sulfate will decolorize. And then the overall reaction, we just add up this equation and this equation, we get actually a displacement reaction where my zinc displaces copper from copper sulfate solution to form zinc sulfate and copper metal piece. Okay, in this above example, Cu2 plus and H plus from the electrolyte. Okay, remember this one is from my copper sulfate solution, and zinc is from the anode. Okay, all these cations migrate to the cathode, and then the copper is preferentially discharged because it's lower and less reactive than zinc and hydrogen in the reactivity series. Okay, so copper will gain the electrons, higher tendency to gain the electrons, and it will form copper solid and increase in mass. Okay, so if I use sulfuric acid, then I will only have Zn2 plus and H plus. And these are the ions that will migrate to the cathode to gain electrons. Okay, so least reactive will be my H plus. I will see effervescence of hydrogen gas at the cathode.